Sodium has 12 neutrons. How do you know? 23 minus the number of protons. How do you know the number of protons? Same as the number of electrons because atoms are
neutral.
Carbon, 6 neutrons. How many electrons and protons given an atomic mass of 12?
6.
Fluorine has an atomic mass of 19 and 9 protons. So how many neutrons does it have?
10.
And how many electrons does it have?
9.
Sulfur, 16 neutrons, 16 protons. So an atomic mass of?
32.
And how many electrons does it have?
16.
Uranium has 146 neutrons, 92 electrons. How many protons?
92.
And what's the atomic mass?
238.
And silver has 60 neutrons, 47 protons, so an atomic mass of?
107.
And how many electrons?
47.
Are we all familiar with how we arrived there?
Yeah.
Excellent. Some of you may have noticed when consulting your periodic tables on Friday that the mass number, I made you do what to it? Round it to the nearest whole number, right? The reason that it exists on the periodic table as a decimal and not as a whole number is because it turns out it's not quite so very simple as we made it sound. Slightly more complicated. Some of you are familiar with this idea already. Some of you, this will be new. So I will tell you, ask you a couple of questions. So when I was your age, I was probably about 100 pounds heavier than I was before this small person came into my life. And then I started running, did the whole half marathon thing. And then I was, what my husband calls my fighting weight, my running weight. And then this small person came into my life and I gained about 25 pounds. Is who I am, did that change? Did my social security number change?
No.
Did my identity change?
No.
What changed? So my weight, how much matter I'm made out of changed, right?
True.
The same thing happens for atoms of any element. They have the same identity as a particular atom. So they have the same number. Which number provides an atom with its identity? Its identity is determined by the number of protons. So the number of protons is always going to remain the same, but the mass is going to change for these particular elements. What's the mass of an electron? What did we call it? We had a funny quotation for it. Virtually massless. So if it's virtually massless, does changing the number of electrons change the mass? So what subatomic particle can we change that changes the mass without changing identity? What, Patrick?
A neutron.
So an isotope of any element, it's the same element. It just so happens that it has a different number of neutrons. It has a different mass. Now, you could understand if I told you when I was in high school and heavier, I behaved differently than I was when I was down to my fighting weight. My fighting weight, I was more active, more energetic, didn't require as much sleep. In high school, more lethargic, So changing my mass changed some of my behaviors, right? Same thing's going to happen for these isotopes. Changing the mass of the element will change its behavior. And sometimes it does so in a pretty big way. Just by adding extra neutrons, we make it radioactive. So sometimes isotopes are radioactive, but not always. We're going to take a look at two different elements that are very common elements, and they are the elements that each have three particular isotopes that exist of that element. So three different masses. One is our friend hydrogen, and I'll do this one for you. H, capital H, that's the symbol for hydrogen, right? When we follow it with a dash and a number, that's the mass number. Now I'll tell you, our friend hydrogen resides in box number 1 of the periodic table, and being in box number 1 of the periodic table, what does that tell you about the number of protons it has? If you are holding up one finger, you are absolutely correct. So it has 1 proton. And since all of these are hydrogen, they all have 1 proton. And since all of these are atoms, they're all neutral. So how many electrons do they have? 1 electron. Hydrogen 1 has a mass of 1 and 1 proton. How many neutrons does it have? 0. 1 minus 0, so 0 neutrons. How many neutrons does hydrogen 2 have? All we have to do is the mass minus the number of protons to get the number of neutrons. So then what does that tell us about our friend hydrogen 3? It has 2 neutrons. Now in the case of hydrogen, none of them are going to be radioactive, so it's nothing we have to worry about. But the one that we do worry a little bit about. There are 3 isotopes of carbon. With your partner, determine the number of protons, neutrons, and electrons each isotope of carbon has. All right, if you got 666 for the first one, you're right. And then from there on out, it increases by 1. Hopefully I'll see you guys tomorrow.